Hello, everyone. Welcome to the second and final technical session in this Summer 22 cohort brought to you by Hamoye. Hamoye is an edtech startup with a mission to prepare young professionals and college students for their choice careers in data and the future of work. We do that via our internship programs, which simulate the conditions which you will face while working in a real work environment. Our internships will expose you to specially designed courses, career coaching webinars with industry experts, and industry-relevant project presentations like what we are having right now. My name is Mercy Okwadoku, and I'm an editor at Hamoye. I'm joining you from Ibadan, Nigeria, and would be your host for today's session. I'd like to welcome to this event everyone present, our incredible interns in these Hamoye cohorts. Kudos to you for making it this far. Thanks to the Hamoye Fellows and the Hamoye team who have made this session possible. And now, for this session, we have an industry expert, Mr. Wale Akinfadere. Adewale Akinfadere is a data scientist at Amazon. He has expertise in machine learning, deep learning, statistical experimentation, and general information theory. He has broad experience in implementing and extending ML techniques to solve practical and business problems. In the past, he has built data veracity models using machine learning and natural language processing techniques for international development and developed ML algorithms to solve problems in the renewable space. He is an advocate of open source and democratizing learning, and his writing on data science and machine learning have been featured on Hacker News, Data Science Central, Data Economy, R Bloggers, and IBM DSX. He has presented in technical conferences like the ML for All conference in Portland and the Google Developers ML Summit. In his spare time, he conducts research on machine learning for the developing world, and he was in the program committee for the Neural PS 2019 workshop on machine learning for the developing world. Recently, Wale has been involved with the ethics professional program at LSC. He also advises startups in the data science and artificial intelligence space. He will be sharing his thoughts and experience on the topic, machine learning, model fairness, and interpretability with AWS. Before I hand over to Mr. Wale, please carefully take note of the following. Feel free to post your questions and comments on slido.com. On slido.com, using the event code hashtag 2597474. I'll repeat that again. The event code hashtag 2597474, and they will be promptly attended to. Also, we need everyone to pay close attention to this, please. A Google form has just been opened to collate attendance for this HDSC Summer 22 technical session. And you will use the secret code GIT, all lowercase, GIT, G-I-T, everything lowercase, no uppercase. The form will be open for only 10 minutes starting now. We have pinned the first attendance form link on YouTube, Zoom, and Slack, and the announcement channel on Slack. We want you to fill your form quickly in order to focus on the presentation. Hope everybody heard the announcement. The secret code for the form that is being put on all of the platforms now, YouTube.
Yeah, we have not received it.
On Zoom and everything.
Yes, on Zoom,
is Git. The secret code for it is Git, everything lowercase. You will receive the form right now as we speak. So you have just 10 minutes beginning right now to fill all of that. And we want you to do that fast so that you can focus on everything that Wale has to give you, and he has a lot to actually give to everyone. Over to you, Wale. Thank you very much.
Hi, thank you for that introduction. I was wondering if that was me or not. Since it's my name. Let me share my screen. I have a question. Can the people on Zoom, can they type in the chat box or not?
Okay. Well, yes, they can, but for now they won't be able to, because we are trying to let them see the form and be able to fill the form. So for now they won't be able to.
Oh, okay. Okay.
Yeah. So after 10 minutes they will be able to do that.
Okay. Sounds good. Yeah, good afternoon, good morning, good evening, everyone, from all over the world. My name is Wale Akinfaderi. I'm currently a data scientist at AWS. And today I'll be speaking on machine learning fairness and model interpretability with AWS. I think they already introduced me. So I used to be a physicist, in case you guys don't know. I did all my degrees, my doctoral research in physics before I transitioned into machine learning. So I'm just saying that so that if you're in a different field now, for example, in social sciences, in the quantitative sciences, whatever field you are, you can always transition to machine learning, and definitely you can be successful. So don't sort of think about your background. All you need to do is look at the elements of sort of quantitative skills in your background and try to apply it to machine learning. So for me, coming from a physics background, I know I could apply things like my numerical skills, my quantitative skills, my math skills, for example, and apply it to machine learning, and that helped me. And I think everyone can do that from their own field. So I'm excited to be here. The way the agenda is going to be today is that I'm going to talk about bias in data and machine learning, how to understand bias. After that, I will talk about fairness, accountability, and transparency. And transparency would lead to me then explaining, talking about interpretability and sort of explainable machine learning. And then I'll talk about SageMaker Clarify, which is a service that can be used to sort of understand, capture bias and to explain machine learning models. And then I'll talk a little bit about how to use Clarify in your MLOps pipeline. It is a lot of slides. It is an entire sort of tutorial on sort of fairness and interpretability. I would see what I can cover in the next 1 hour, but I hope you guys would go on this journey with me and sort of understand why this topic is important, and also sort of understand some of the tenets of how to build sort of machine learning models and consider bias and fairness when doing it. Okay, so I actually really like, I think the last time I gave something similar, I started with this slide deck, which is, which I call machine translation, 4 peaks and 1 word, right? And that was why I was asking if anybody can type, when you see these 4 images that I have, what's the first thing that comes to your mind? You can just type it, even easier, yeah. No one is typing. Can everyone hear me? Okay, someone's in machine translation. Okay, that's the first thing that comes to your mind. Good. Okay. Now, if you look at the words, and so what I've done is that I've used a sort of translation to take the English version of "she's a doctor," right, to Oje Dokita. So that's Yoruba, because I'm Yoruba. And then I took like the back translation, that Oje Dokita, and instead of it to translate it back to "she's a doctor," it has translated it to "is a doctor." And the same thing is I did with nurse, so which is a nurse and nursing it, and then translated back. And instead of translating back to "is a nurse," it is sort of "she's a nurse," right? And so this is an example of sort of machine learning products where you can actually sort of see bias in action, right? I don't know about everyone, but I have met many people in Nigeria, Yorubas that are doctors, right? And many female women that are doctors. And I've met men that are nurses too, right? And so this is sort of an example where you can see bias in action in a product that is being used by billions of people. Okay. And then the next one is what is bias, right? So bias is that you can have a group. You can say that you can have two types of group. You can say one is a favored group, who you're favoring, and then the other one unfavored group, right? So when you have a prejudice against a person or set of groups, or set of features that defines that group, right? That's when you are actually sort of perpetrating bias. So that's what bias is, especially, and bias could be data in your data, and you could also have bias in your machine learning. So data bias is the case where you kind of have like real world data, but your real world data is not the same as the data and the features that you have collected, right? So sometimes one is that a lot of people, you don't have the capacity to collect all the data in the world. And then when you sort of try to featureize this data set, maybe you try to take the data set and maybe extract some important features, it is very possible that there's going to be data bias within the process. And this has been discussion for a while, which is bias in machine learning, right? So if you have a process that is unfair, and that leads to a biased data, and then you're trying to do some automation or some machine learning on it, what it actually does is that the outcome from your machine learning model is being amplified. And so times and times and times when you are actually using machine learning on data that is biased or data that is gotten from an unfair process, the outcome is actually, the unfair outcome is going to be amplified in this case. And so that's sort of the definition of how you see sort of bias in machine learning. A good example is that you have an unbalanced data set. And I think if you've been doing machine learning for a while, so let's say you have orange samples and blue samples, and you can see that the data is highly unbalanced, which means the ratio of the majority samples to the minority samples is pretty high. And then you sort of build your machine learning algorithm, and then you use this machine learning model that you've developed to make predictions, right? So what happens eventually is that your prediction is going to be skewed to only the majority, right? And so, and there are a lot of things around sort of handling imbalanced data, what's the right metrics to use, but this year predictions is actually always skewed to the majority, which is you're getting predictions for most of the orange samples. Yeah. And then the next thing is why understand bias, right? And I think I would go to how can bias affect your customers? So you could think of, I'm trying to put the interns in a position where they are like data scientists or machine learning practitioners in some of the big firms, right? So they could be working in the banks, they could be just working anywhere, but they're trying to think about how bias affects the customers, right? So the first one is in credit decisions, right? We see it a lot of times. I like using Nigeria as an example, and I'm going to use Nigeria as an example. So let's assume that you're hired as a data scientist to build a credit risk model for one of the microfinance banks. So let's say Lapo, for example, and they decided that they actually want to use machine learning to decide if they're going to give credits to their customers, right? And then when they check, they actually notice that the data they have in terms of like maybe they have income data, the different demographics, just the different features that they have are only from the states in the Southwest, right? Which is let's say Lagos and Oyo State, for example. And then they are trying to find a way to use that data set and that model to make decisions in the North, for example, right? And so that's an example where it can actually affect your customers because you're actually using a data from a different sample to sort of make decisions or sort of make inference for a new market that you're trying to get into. So yeah, bias could affect when you're trying to make your customers, when you're trying to make credit decisions. It can also happen when you're doing marketing of products, and we've seen that a lot of times. Educational opportunities also, it can, and that's why in some cases when you apply to grad school, for example, they will tell you that they're using sort of some holistic view to actually view your application. So they're not just looking. You can think of essays, for example, English essays, right? Someone from a very strong English speaking country, it's very likely that that person will be able to write a sort of much better essay in English than someone from a non-English speaking country that did not grow up learning English, right? And so in that case, what happened? It doesn't mean the person from a non-English speaking country is actually not intelligent or not brilliant enough to get into a program. But now it is a difficult language to write in, and it's entirely probably new to the person. And so that's where sometimes bias can actually affect when you're trying to make decisions on sort of educational opportunities for people. Government services. I have actually met someone before that was using machine learning and data to make decisions on who makes the jury. So the jury, for example, in the US, they actually come together if there's a court case, and something like that. It's very possible that it can actually affect government services, and we've seen it. We've seen a lot of reports around that. And then in healthcare, which is extremely important because sometimes maybe the racial makeup, demographic makeup, the sort of socio-demographic features of a particular group is different from another group, right? So bias can actually affect customers when making healthcare decisions. Okay, let's do bias in machine learning. And the first thing is when you're thinking of bias in machine learning, you start thinking about systemic errors in data, right? So so you could have systemic errors in your data, so which is the processes and the instruments that you're using can actually introduce systemic errors. So one thing that a lot of people ask me about, in especially upcoming machine learning practitioners, they ask me, they say, oh, I have this data, but some of the data are missing. What do I do? Should I just do a mean imputation or a median imputation or some imputation, right? That's the first thing that comes. But sometimes you could actually have missing data that are actually due to systemic errors. So which is maybe someone is not entering the data very well. Maybe someone is not putting the data in the right place. It could be database error, maybe the queries are not working well, or there's a mistake there. So you could have processes and instruments that can introduce systemic errors in your data. And so, so in this case, for example, that I'm showing you, let's assume that we still have this educational data where you have age, gender, parental education, and final grade. When trying to take this data and impute it, you could have systemic errors. I think. And so, for example, some of these systemic errors could be incorrect final grade. So like I said, you're trying to impute this age, gender, education, and final grade into sort of this tabular structured database that you have. And some of the final grades can actually be incorrect. Maybe you want to put it an 80 or 90 and you put a 9, for example. You could have things like that. And then the next one is that not all features can be measured. In some cases, there's some cases where there's some features that you just cannot measure and therefore you cannot use them. And so, so in this case, I talked about incorrect final grade, but sort of feature selection, for example, is like, you have your data, and for some reason you don't have features for health conditions, and sometimes also maybe because you already put in PI data, but some might actually, maybe for example, you have a student that was sick, maybe after time during the semester, and sort of couldn't get a good final grade like the others, right? So if you cannot sort of have features for this health condition, for example, you're introducing bias into your machine learning model. This is extremely important because you cannot collect all data that you need over all the time. So it is just very difficult for you to be able to collect data, all the data that you need. So, and with that, you sort of get into this sampling bias. So which is, you're actually trying to take this data, but you need to be able to collect enough data. How do you determine the sampling rate? Do you look at the laws of large numbers for you to be able to know the optimal number of samples that you would need? So when you sort of get into this, where you have to decide, there is always that bias due to your sampling techniques. Yeah. So the sampling bias, for example, is that you're taking different data, and then you now notice that, actually, the students that are taking maths, you don't have their data. And then that's a problem in this case. So no math student data. Now, this one is very important because as humans, there's this human bias that in some case, for some people, it is intrinsic, it is sort of inherent, and in their subconscious, they probably don't know that is human bias, but it is there. And sometimes it's actually important for you to think about this and consider this when you're building, when you're thinking of building ML models that is fair. And okay. And example of that is someone that is trying to get features for this, and then the person just sees, this is an alumni from my school, or this is someone that I've met somewhere, or I know the parent somewhere, right? And I mean, even if it's not machine learning, we see that happen every time in sort of governments and maybe some workplaces where in that case they call it nepotism. But you could also have this sort of inherent human bias that you would want to favor some group because you have a connection to them. And so eventually what happens is that if you have all those different bias, right, your incorrect final grade due to some sort of systemic process, no math student data due to some sampling bias, you're favoring the alumni due to human bias, and you don't have features for health conditions because you actually cannot collect all the data. And then when you take these and you build a machine learning for it, what happens is that you have an unfair outcomes. Your outcome definitely will be unfair because now you're taking sort of these unfair processes that led you to getting this data, and what machine learning does is actually amplifies the unfairness. So the first thing that I wanted to say is that always understand your data distribution. I think it's extremely important. If you have a data, your data set, understand what's the gender distribution. So no matter what sort of machine learning model you're trying to build, understand the data distribution actually helps to sort of find bias, it's the ones that are inherent, the ones that are due to systemic processes. So in general, or even outside understanding data distribution, just really, really good exploratory data analysis actually helps with that. So this is understanding your sort of your data distribution over time, and sort of know the ones where you sort of have some bias in the data set or not. So that's important. Which is 926. Okay, so now let's talk about fairness, accountability, and transparency in machine learning. So the first one is actually before. Okay, let me continue. Maybe 9:45. I'll ask if anyone has questions. So the first one is fairness in machine learning. So for fairness, you want to understand the bias you have in your data. You want to understand the bias in your models and how your model actually amplifies this bias. If you build a machine learning model and you're trying to run inference on that, you want to monitor the changes, and you also want to adjust for fairness. So that's extremely important. And so these are sort of processes for sort of fairness in machine learning. How do you address bias and fairness, right? So which is, this first thing is very important, is data quality, in improving data quality. So if you have like an underrepresented group, right, can you get more data for that underrepresented group? Can you improve the process of you selecting features? Can you also monitor changes in your data? So if you have a sort of high velocity data, like streaming data that is coming in, you also want to sort of monitor the changes in the data in real time. Sometimes rebalancing the data works. I think also when rebalancing data, one needs to be a little bit careful. So which is, you want to do data augmentation for underrepresented and data filtering for overrepresented, right? And so the reason why I said one also needs to be careful is that if you have a data set that is highly imbalanced, you can also run into the trouble of introducing too much noise to your machine learning model when you sort of do data augmentation, which means mostly what you're trying to do is oversampling the underrepresented group in this case. And for data filtering, if you sort of filter, let's say, for example, you have a data where you have 99.99% or something of majority group, and then the underrepresented group is 0.01 or something like that, right? When you sort of take this 0.01 and you try to oversample it, you're definitely going to be introducing some noise to your data set. When you filter the 99.99% down to sort of the minority group, you can also lose a lot of signal from the data. So rebalancing data is good, but one needs to do it carefully. Machine learning, you could actually train your model and include some fairness constraints. Actually, there's some metrics that you could look at, that you could check and sort of put these constraints using these metrics when you're training. You can also select your model based on fairness criteria, and also you can monitor changes in your model. So if you have a model where you have to like keep on developing the model over time as data comes in, it's always good for you to be able to monitor changes in the model. And then the last one is the process, right? So make sure that your processes can adjust for when you have machine learning fairness problems, and then also make sure that some of your decisions are sort of data driven, right? So every decision that you make, build analytics for it, understand it, and with that, you can actually improve your process as a means of addressing bias and fairness. And then the next one is sort of accountability in machine learning, which is, so the first one I talked about data and machine learning, and now I'm going to talk about process and decisions. And this accountability, right, recurs to human escalation process. Sometimes, I mean, someone once told me something that when you're doing machine learning and you're thinking of, oh, is it interpretable? Do I want to explain the model? Sometimes it doesn't really make sense, because the best thing you could do is to sort of have this human in the loop, right? So make sure that there's human escalation process that is very solid, that you can actually audit your machine learning decisions, you can audit your processes, and you can make sure that every decision is contestable, right? And so that is extremely important. And accountability already, there's some frameworks, some compliance frameworks that they already have something similar to accountability in their in whatever they're doing. So one of them is GDPR, for example. So when you make any decision for humans or EU citizen, they actually want it to be transparent, and they want it to be accountable. So you can sort of actually explain, and the EU citizens or the human can also contest these decisions. Before I go to, okay, yeah. So the last one is transparency in machine learning model, which is now this takes the machine learning, the process, and the decisions. And first is transparency is interpretable models, and then clear process and explainable decisions for customers, right? And I've seen a lot of people sort of use interpretability and explainability. They use it interchangeably, right? They're not necessarily the same thing. I can give you an example, right? There's some criteria for you to be able to say, oh, this is an interpretable model. But what explainability does is that it takes a model that is non-interpretable, a model where the process and the decisions are non-interpretable, and then build post hoc explanations for it. So after you've built your model, and then you can do explainability, and you say sort of explainable decisions for your customers. And so the second half of this course is actually for me to talk about model explainability. Before that, I'll probably take maybe 2 or 3 questions, and then I'll continue. And if there are no questions, I can also continue. So. And if there are no questions, it means 2 things. Maybe I'm not doing a good job, or I'm doing a perfect job. And I'm sure it's probably not the latter. Okay, let's go. So for
Hi, Wale, sorry. Someone asked a question just now in the chats, in the Zoom chats. The person said, what is bias? And they said to tell you are doing a perfect job.
Oh, okay. I can say it. Yeah. I mean, I've used the last 30 minutes explaining what bias is, so I'll skip that.
Okay.
Yeah.
All right.
Yeah. So I'll go to model explainability. Is now. So let's go back to the data set that we have, right? And you have the one that I was explaining then, that you have a linear model and you want to predict the final grade. So final grade given, I mean, the age, the gender, just all the information you have, right? And the parent's education. So you take a simple linear model, the data set is not very large, and you build a simple linear model, right? And then, you have, your final grade is a factor of 0.02 plus female times this plus age times this. And so you have plus parent education times 0.3, which gives you final grade. So which means that you sort of have all these numbers, or all these coefficients, for your linear model, right? And so what happens in this case is that these are your feature importance, right? These are your feature importance because they explain how each factor contributes to you predicting what the final grade would be, right? And so in summary, what this is telling us is that, your gender and your parents' education have the most influence on determining school success. For example, using this example, right? Now, let's take the same data set and say that you want to use a non-linear model for you to actually not predict popularity. I think that's an error, to predict your final grade, right? So now your non-linear model, your result looks like this, right? 0.02 plus female times age times 0.1, age times education squared times age cubed, because it is complex, right? And so now what you have is your feature importance, right? But you necessarily don't know what it is from this, right? Because now you have sort of this really complex nonlinear model, and you don't really know what the effect of age is, what's the importance of education or age, because now what you've done is that you've actually increased the complexity of the model that you're using. And that is where sort of explainable machine learning model is, where you sort of do this post hoc explanation based on the model that you've developed. There are a lot of them, but for this session, I'm actually going to talk about SHAP, S-H-A-P, and explain how SHAP actually came from something called Shapley values, and how you can use SHAP for explainable machine learning. So what SHAP does is that it actually computes the importance of each feature. Every single feature that you have, it can actually compute the importance post hoc. It is model agnostic, right? So it doesn't matter what your it doesn't matter what your machine learning model is, from complex, like from sort of ensemble, like tree-based like XGBoost to like deep learning algorithms. It works with anyone, so it's model agnostic, right? And then the last one is that sometimes when you use models like random forest, or they'll give you something called feature importance, right? But those feature importance are actually global interpretation, right? So they tell you how your model would work globally, right? But what SHAP does is that for every instance, that you actually make prediction on, you can have local interpretation. So it can determine the relative influence of features for a subset of model prediction. So it could be single, it could be a subset, and they sort of have like these SHAP values. And then your global interpretation in this case is an average of all the SHAP values together. And so that is what SHAP does. I'm still going to explain some of the sort of intricacies of SHAP, but the next thing I want to quickly just run through is sort of why do we need model explainability? And I think I've explained a little bit. And so in some cases, you need it so that you can audit your model, and you can also meet regulatory requirements. So in the US, in finance, there's something called sort of the consumer finance. You want to build trust in your model. For regulatory, just GDPR. Sometimes I think the FDA are about to require it. There's GXP, and so many sort of regulatory requirements and compliance. You want to build trust in your model. You want to make sure that you're supporting human decision making, right? So, for example, you build a model and it says that, oh yeah, this person from my model and the data set, this person has cancer, right? You need to be able to explain why, because that would then support whatever decisions the doctor is trying to make. And also helps you to debug. and sort of improve model performance. This is a sort of brief chat where we talk a lot about this accuracy interpretability threshold, which is also, this is like, oh, there's some like linear models are very highly interpretable. The accuracy maybe not so good, but you have things like XGBoost and neural network without much interpretability. They're difficult to interpret, but they give you high predictive performance, right? It could be your accuracy can be replaced with any other metric that you're looking at. Okay. And then and so I actually want to talk a little bit about feature attribution process, right? So there are a lot of so you attribute, like what you do is you attribute the model's prediction on an input to features of the input, right? So for example, if you're building a lending a model predictions, you attribute that lending to its feature. So the features for lending could be what's the income of the person, what's the credit score, what's the risk, what's different things. Object recognition, you attribute it to the pixels that you see in the image, and then for text sentiment, you actually attribute it to the individual words that you see. So these are examples of attribution, and attribution methods are actually used for explanation. So what we're trying to focus on in this case is that we're focusing on feature attribution approaches that you can use for both for the global understanding of a model after training, and also for providing the explanation for each instance during inference, right? And so and that's what SHARP does. So there's SHARP is sort of this Shapley Shapley additive explanation, which is based on the concept of Shapley value. So it's actually from game theory. So what it does is it assigns each feature an importance value for a particular prediction, and with that you'll be able to do sort of post-hoc explanation. And so the different type of attribution, there's ablation, where you drop each feature and attribute the change in prediction to the feature. There is the gradient-based method. There's one called integrated method, integrated gradient methods that I've actually used for text before. And then also there are other methods that you can use for example, for back propagation, which is actually specific to neural network. So these are the other like 3 attribution methods. And for us, we are mostly focused on this one, which is these game theory based methods, which is the Shapley methods. What's the time? Okay, we're still there. Okay. Now the next step, the next step for me is to, oh, someone is asking. Okay. So the next step for me is to sort of explain how feature attribution works during Shapley value. I'm using Shapley value. So this is actually an intuition from game theory. And so we have adopted the concept of these Shapley values from game theory, and then it can be deployed in the machine learning context. So what the Shapley value does is that it quantifies the contribution of each player to a game, and hence provide the means to distribute the total payoff generated by a game to the players based on their contribution. And so next is, like I said, it's a fair way to quantify each player's contribution to the game's payoff. To sort of build the intuition of these Shapley values, right? So let's assume that you have these coalitions and you have players P of I, and you want to see if one of them plays alone, what would the payoff be, right? So the payoff, if you have P1, the payoff is 25. If you have P2, the payoff is 100, let's say in dollars, right? If you have P3, the payoff is actually 150, right? But what you can see is that this could be problematic because, I mean, P1 plus P2 plus P3 is what? That's like 275 or thereabout. But when you sort of have them played together, so you add P1 into a game with P2, you add P1 into a game with P3, you add P2 into a game with P3, you add P1, P2, P3. So this sort of coalition, you would see that you then have a sort of much higher, better way to sort of understand what the payoff would be, right? And so in this case, you see that it is fair for you. You're not assigning, you're not only assigning a contribution to P1, but you're considering both the payoff with P1 as the sole player, but also how the payoff improves as you add other players to it, right? And so that is exactly what Shipley values is, and that is what it does, right? The Shipley value of a player PI is the marginal payoff over all the possible correlations. So what's the payoff if it's P1 alone versus the payoff if it's P1 and P2 alone versus the payoff if it's what P1, P2, and P3 together, for example, or P1 and P3. And so that's what Shipley values does. It actually works under 4 different axioms. These axioms can actually be justification for it. And sort of these 4 axiomatic properties are like, if a player never contributes to the game, you receive 0 attributions. One is efficiency, the other one is symmetry, and then the last one is linearity. And what happens is that these Shipley values is actually the solution that satisfies these axiomatic properties, right? And now, we've been talking a lot about Shipley values and game theory. How do we relate this to machine learning, right? In this case, as you can see, your game payoff is the model prediction, right? That's the F. Your players actually is the same thing as the different features that you have. So you could think of this as, let's say you're trying to build a credit risk or a credit lending model. You have the age of the account, for example. So one thing you can do is that, what's the effect of the age of the account alone? But that is not enough, right? Sometimes the age of the account and the income over the years, if you combine that, maybe that actually gives you a much better game payoff or a much better model prediction in this case. And so the subset of players are the subset of features. The specific players are actually specific features. And the instance that you explained is the same thing for machine learning. And so in summary, this is what it looks like. In summary, this is what the sort of open source, the Sharp implementation looks like, right? So the Shipley value for the contribution of each feature, which is the contribution of features to the model prediction, is actually the average over all the feature offerings, right? And so there are a lot of implementation. There's the ones that is mostly that we use a lot is the kernel Sharp, which is, I think it's open source. There's a link there. So it has the training set. It also fill missing values from the background data set that you're giving it. And so sometimes it does like a k-means representative of all the data set and maybe inputs using the median also. And so, and this is how you can actually explain sort of model predictions using Sharp algorithms. And so the one reason why the kernel explainer of Sharp is good is that, I mean, it solves for runtime complexity by using approximations. It is model agnostic. I think I mentioned it. It calculates the approximation and not the exact value. There are other ones also that I've used before. There's one called Lime, which trains a linear model and approximates the big model to explain the sort of main model around a specific point. Also pretty good to give you sort of local explanation of your model. But for this talk, I'm mostly talking about Sharp implementation. Okay, now so I don't know how many people have used Amazon and SageMaker. Yeah. So SageMaker is an AI services from AWS that you can use end to end to develop, train, and deploy a machine learning model. So with SageMaker also comes something called SageMaker Clarify, which you can use to sort of explain your machine learning model and assess your data and models for bias. If there's a bias in your data set, you can use it. The first thing it does is that it's integrated with something called SageMaker Data Wrangler that actually makes it easier to identify bias during data preparation. So when you specify your attributes that you're interested in, it could be gender, age, and what SageMaker Clarify does is that it runs a set of algorithms to detect any presence of bias. So there's a lot of sort of metrics that it looks at and to check if you have bias in your data set. And then the next one is for your train model. So you can actually also check your train model for bias. So you want to check the predictions that produces a negative result more frequently than another. And also after you train your model, you can also, so it has something, it's integrated with something called SageMaker Experiment that you can identify attributes that you like to check for bias. And so it also does similar thing, but also for this, it is for your train model. So explaining your model prediction, in this case, sort of your overall model behavior. And so you can actually use your train model to have a sort of a graph that gives you an overall model behavior. So it tells you which features contribute most to your model predictions. And you can use this for compliance requirements or for you to establish trust with your model. Also, I think I mentioned these individual predictions, which is sort of this individual shapely values that you have, and Clarify also can do that over time. And then it can also monitor your model for changes in behavior. And so there's something called model drift and data drift. So over time, if you deploy a machine learning model and there are changes and there's a drift, and so because you would always get changes in real world data, right? So, and what you can do is that these changes can actually give different weights to your model inputs, and then it changes the behavior of your model over time, right? So, so for example, let's say you're building a model where you're trying to determine what home prices will be over time, but maybe because there is a pandemic or home prices just crashed or something, right? It means that now it's probably going to weigh income and your house price is going to be lower when trying to make a loan prediction, right? So so it detects this drift and bias over time, and it's a pretty good heuristic because it can actually give reports to your auditors. So which means there's a dashboard where you could have like a sort of Clarify report that tells you the bias in the data set, bias in the model, explains, like the model gives a global interpretation, and you could have like sort of these reports that can be used, presented or given to people, to auditors. And then this last part is MLOps, so which is the good thing also is that when you measure for fairness and you want to check, you want to do explainability, it's always good to be able to have it as part of your MLOps pipeline. So you can actually integrate Clarify across your the machine learning lifecycle. So if you collect and prepare your training data set, Data Wrangler can measure your bias metrics. You can use so Clarify autopilot. You can measure and tune your metrics, and you can measure your explainability metrics. You can sort of evaluate and qualify your models, and you can also do that when you're using SageMaker processing. when you deploy your model in production, you can catalog all your model metrics with hosting. And when you're monitoring your model in production, you can actually monitor the bias. So your bias metric drift, and you can also monitor explainability drift if there are changes while you have your model in production. And so you can, like I mentioned, you can do MLOps with SageMaker. So which means I just explained this, which is your feature construction with data wrangler, train and validate with SageMaker training, your model repo, which is based on ECR, and then you can use Clarify for model bias and explainability. And so this is actually where you are plugging sort of Clarify or identifying model bias and explainability into your entire machine learning operations lifecycle. And then also when you deploy and monitor, so you can use pipeline for deployment, and then you can also use Clarify for sort of model and data bias, and you can monitor your model real time. In addition, I mean, AWS also has something called Lambda to trigger your retraining. So you can write these Lambda functions as an event trigger that if you're monitoring your model and you see that there are changes in your sort of explainability metrics or your data bias, the bias from the data you're getting over time, you can actually, based on the threshold that you set, you can actually trigger for your model to be retrained. So there's an alarm, and then it goes back and it will do that automatically. And that's why everyone wants to do MLOps, so that you can have some form of seamless operations for your entire machine learning pipeline. And so I think that's pretty much everything I want to cover around bias, fairness and accountability and transparency, model interpretability and explainability with Sharp, SageMaker Clarify, and how you can use Clarify with your MLOps. And so with that, thank you very much. Ooh, I did it in 1 hour. Okay.
All right, thank you so much, Wale. That was very insightful. I'm sure everybody was wowed by that. That is a whole lot. Wale actually has had a whole lot more planned, but because of the time, would the slides be available? Because I know they were asked that the slides, would they be made available? Would you be able to give it to us? So
yes, definitely.
Right. So there you have that answer. That is a question that nobody should ask anymore. All right. So thank you so much for that very insightful session. We are really we have learned a lot, and I'm sure everybody in attendance has too. Thank you. Okay, just before our speaker takes some of your questions, please note that the second and third attendance form will be dropping now, and the secret code is Kubernetes, plural, all lowercase, Kubernetes, Kubernetes. So everybody should they will be posting. Remember that form will close in 10 minutes from now. Just check YouTube, Zoom. It's going to be pinned on Zoom now. It's going to be there. And after that, we can now, there are some questions that are already on Slido, yeah. Okay, so guys, remember to post your questions and comments on slido.com. And remember, the event code is hashtag 2597474. They will be promptly attended to. Okay, so some of the questions that we have, let me see. We already have some questions. While you were asking if anyone had questions the other time, some people already asked questions.
Oh, okay. Yeah, let's have it.
Someone said, I would like to get the difference between, that's AK Mong, AK or something, that's the name of the person. I would like to get the difference between error and bias, because it seems it's being used interchangeably in this webinar.
I don't think I've used error in this webinar. I'll definitely be careful now. Yeah, some people use it interchangeably, but they're not the same. So when you talk about error, you talk about error for a single measurement. right?
All right.
Bias is the average of errors of many repeated measurements, right? So you could think of bias as a statistical property of an error, right? And so sometimes I've seen people sort of use them interchangeably, but they're different. So error is due to a single measurement, and bias is the average of errors.
Okay. Hope AK is all right with the explanation. All right, so Asif asked if we can have real-time implication on AWS in this session.
Sort of, I don't understand the question.
I'm not sure I understand the questions. I think maybe what the person meant to ask was that, can we have real-time application of AWS on this session, like Amazon Web?
Yeah, so I don't understand what real-time AWS is a cloud services where you can build your application on, so you can sort of develop your machine learning model, get your bias metrics, and do explainability. And there are a lot of, I mean, think about any company that comes to your head. If you think of 5, at least 4 of them somehow actually use AWS, right? And so a lot of these companies, they use it for developing sort of their machine learning models, and also for operationalizing their machine learning model, so end to end. And now what this does is it just gives you an opportunity to also use clarify and add sort of explainability and data and model bias to your pipeline.
All right, thank you very much. I hope Asif has gotten his answer. Okay, this Sonola Muyo person asked if he said, my question, kind of not a question, is that can you use, I think it's quite similar to the first one, the other one I read.
Okay.
Is that, can you use real life scenarios you have encountered to explain the bias fairness concept and other concepts to be discussed? Great job, thank you.
Yeah, so I've already sort of used a lot of scenarios around.
Yes, the person asked while you were asking
okay.
question, so I think that can slide. Yeah. All right, Muhammad Balogun asks, what are the techniques that we can use to improve the quality of our data?
Oh, that's a good question.
Yeah.
Oh, that's a 1-hour webinar.
Okay.
There are a lot of things, but I feel like the first thing is to define what quality is. I mean, I'm talking about if you're in a company, right? So one is to define what's the definition of quality, and then after that you start to define the metrics. So what I would call quality metrics, right? So quality metrics could be data completion, even data bias could be part of your quality. You could also have metrics to check sort of systematic mistakes, or if you sort of have like if you have missing data, for example, how do you check and how do you sort of qualify the quality of your data set that has missing data, and then how do you impute? So there are a lot of different methods that you could use, but I feel like the first thing is sort of defining what quality means to the company or the firm, and then defining metrics that you want to track over time. And what I've seen is that some big companies, they actually do have like data quality team. So they have like quality control specialists that looks like at your data, because I'm sure all of us, we all know that sometimes machine learning is garbage in, garbage out. You give it data that is not of a certain standard, your result is also not going to be of a certain standard. So yeah.
All right, well, thank you very much. Okay, Anonymous asks, in the case where getting more data for the minority group is not possible, which of the imbalance handling methods would you recommend?
This is putting me in a box. Yeah, I'll get out of the box now.
Okay.
So for me, the go-to for me in most cases has always been smooth.
Okay.
So which is the synthetic minority oversampling technique, and I can't remember what it is. And also I've worked on imbalanced data set, but I have not worked on imbalanced data set that are extreme. And the reason why I kind of like smooths better than maybe me doing a random oversampling, because smooths actually adds lesser noise to your model than maybe doing a random oversampling, for example, right? So because what smooth does is that uses sort of nearest neighbor extrapolation to sort of oversample your minority class. So that's what I've always done. I haven't, it hasn't happened to me, but I've met people so I've met someone that used to work for a finance firm and was building fraud detection models where your data set, maybe out of 2,000, maybe 2 or 3 are frauds, right? That's an extreme sort of imbalanced scenario, right? And for that person, I mean, the person told me most times smooth doesn't really work. And they've had to come up with their own technique, a lot of things that I probably don't know about. Maybe I know some of them. But yeah, but for me, in most cases, smooth has actually been my go-to. Yeah.
All right, thank you. This Mohammed asks again, how can I secure an internship with AWS?
How can you secure an internship with AWS?
Yeah.
So I can definitely answer that. In most cases, it actually depends on the country that you have.
All right.
But we have like internship programs. Actually, they come out. So for next summer, well, in the US, called summer, which is from maybe May to August. The internship actually just came out recently. So it comes out around August, September. So you start applying, but you have to check your country. So in Africa, I think we hire in South Africa, in Cape Town.
Okay.
So there's AWS in Cape Town. And so there are a lot of but mostly it's around cloud engineering role, which is like general cloud engineering role or solutions architect. But for those roles too, if you know machine learning, it's fine, right? But some of them, they want you to sort of show that you know AWS. So it depends on the country. Sometimes what I've done in the past is I've given referrals to people. It's a little bit overwhelming, but if you're in a certain country where there's AWS and you're looking for like a full-time or an internship position and you want the referral and you're strong candidates, add me on LinkedIn and send me a DM. Yeah.
All right, you've heard that. I want to add my own question to this.
Sure.
Is there a future for Africans in AWS? I mean, are they looking to move their base anytime into the core of Africa, aside South Africa?
Yes. So there've been a lot of discussions around it. For example, I know that one of the things that they're trying to do now is sort of I won't say test the workforce, but for example, in August, AWS had like a recruitment drive in Lagos. They basically came to Lagos to recruit, but mostly I think for that is software engineers, to recruit software engineers and to take them to Canada or wherever they want, or UK or the US. So they came directly. And when companies start doing that, it means that they're starting to think about sort of possibility of expanding. Because, think about it, I think the latest data that I saw is that by 2050, if not less than that, more than half of the world youth population would come from Africa. And so there is really a lot of untapped potential. And yeah, that's possible.
All right, so everyone has heard that. Florence asked, please, what's the difference between Amazon's Sage Studio and SageMaker?
What's the
difference between Amazon Sage Studio and SageMaker? That's
the same thing. Sage Studio is SageMaker Studio.
Okay.
Yeah.
Clarify. Okay. David asked, how is SHAP, that's SHAP, different from the other feature selection methods such as variance inflation factor?
Yeah, Sharp is not a feature selection method. So so VIF is a feature selection method that I think is based on the linearity property in your data set. Sharp is a post hoc explanation. So you basically do Sharp after you've built your model, and then it explains the contribution of the features to it. So a little bit different.
A little bit different. Okay, Issa asked, can you please recommend any GitHub repo where the implementation of Sharp explainable ML framework is highlighted?
Yeah, for that, I think just go to Google and type Sharp implementation GitHub, it will come out.
Okay, Google that.
Yeah.
Are there any more questions? That is actually the last question on here.
Okay. I mean, I can be on to I mean, I still have some time until like 10:30 my time. So if there are questions, I'll still take them.
All right. I'm seeing one now.
Okay. And also it doesn't.
What advice do you have? Okay. Continue, you were saying.
No, I wanted to say it doesn't necessarily have to be on sort of the topic that I just gave, just general questions, I'll take them. So yeah.
All right. What advice do you have for someone who wants to take assessment test, technical interview, and teaching demo for session lead, AWS machine learning? Did you hear that, Wally?
Yeah, I got it. I'm still trying to process the question. So
okay.
I think this is in general sort of interview advice.
Yeah.
I don't know about assessment test. I never took that. But in general, I mean, advice for interviews is that be as prepared as possible. Ask your recruiter a lot of questions. So which is, yeah, if your recruiter say you're going to have a technical interview next week, don't just say yes, thank you. No. What should I prepare for? What's the interview going to entail? How many people? What areas should I cover? And recruiters would always give you that information. And I know people don't ask that, but always ask your recruiter that question. Do mock interviews. I know a lot of people don't like mock interviews because you don't want to be vulnerable, right? You just feel like nah. But it's always good. I know for me, when I started machine learning, one thing that I did was that I surrounded myself with machine learning. So some of my best friends, right? Like I mean, some of my best friends right now are actually, I mean, one is a data science assistant director. And the other one is like a senior machine learning engineer. And those are the people that I surrounded myself with from the beginning so that I can always discuss technical stuff, ask them questions. And then there are also areas where maybe I have knowledge gaps. I can always ask them for help. So always surround yourself around, always surround yourself around people that can sort of help you, that can do mock interview for you and sort of assess your readiness. Yeah.
All right. So Anonymous heard that you are supposed to surround yourself with people who are sort of maybe where you are hoping to get to. Yeah. Okay. Is there any relationship between model fairness and optimization?
No. So I mean, when you're building your machine learning, what you're doing is you're optimizing, right? So you in machine learning, you have an objective function, right? And so you're actually sort of your objective function, and whatever you do after that is actually doing an optimization technique, right? So in deep learning, you're doing a gradient descent, or you're doing a stochastic gradient descent. That's optimization. So which means you're optimizing to get the best possible parameters for your models. So yeah, it will be different.
All right. Okay. Can AWS, that's a question from Additional.
Okay. Can I see that? Can AWS professional certification improve one's
chances? Yeah.
Yes and no. certifications are actually really good, important, but in most cases, people want to see what you've used the certification to do, right? So for me, I've had questions around, should I do the certifications or what should I do? I think it's much better for you to develop a portfolio. A better portfolio for me, I think is better than certification. I mean, I can give you an example, right? So when I joined AWS, I did not have any certification. I probably used AWS once, right? And I don't think they really cared about that when I interviewed. They just wanted to know my portfolio, what I've done before. I wanted to know if I know my machine learning, which I think I do then. And so in most cases, spend more time developing a portfolio, right? I know in the past for Amoy Passport, I've actually given a talk on how to develop machine learning portfolio. Maybe if I have time, I might ask them, I might ask you guys to bring me back again to do that. But developing portfolio is very, very important, which is, and I'm not talking, well, sometimes I feel, I'm not really talking about portfolio with data from Kaggle. I'm sorry for those of you that have used Kaggle before, but sometimes you want end-to-end portfolio. You want it to be unique. You want it to be different. And you want to be able to make sure that you can speak to what you've done from beginning to the end. So portfolio is good. If you add certification to your portfolio, then that's what I would say you should do. First, focus on portfolio, and then you can start doing certifications if you want to. And one is cheaper than the other. So I think portfolio is cheaper than certifications.
Certifications, yeah. Okay. So portfolio first, certifications come next after that. So yeah, additional, hope you got that, and every other person that might need to know that. Jane is asking, how can a graduate of data science and AI get internship placement in the UK? What's the time frame for application?
For AWS in the UK. Now I don't know if the person is undergrad or masters, but the problem with I don't know if AWS actually hires interns for masters in the UK. And the main reason is because master's degree in the UK is a 1-year program without the ability for you to do internship in between. And so I am not sure, but what I can tell you is that just go to amazon.jobs. And then just search for intern. If they ask for location, put UK. If you see something, send me a message on LinkedIn. Yeah, but I'm not entirely sure. I know of like North America and other countries, but I'm not entirely sure about UK.
Okay, it's all right. Amazon.jobs, everybody get on that and see whatever opportunities you can get for yourself on there. Okay, someone asked, what's your advice for us transitioning into data science? I'm guessing maybe from another course of study. Maybe someone that read something like, say, home economics, something completely and utterly different, just interested in data science. Asking, what's the advice? Yeah.
So what is it? I don't know if the person is on this. Is the person on this chat or Slido?
I believe the person is on YouTube.
Okay, because I would have loved to ask the role or the field that the person is transitioning from.
Okay.
So
maybe we can hold that thought until we get the field person. I'm sure the person is listening. The person should be able to respond. While we are holding off on that person, someone asked here, okay, maybe this person is on Zoom. It says, what are the internship role at AWS for an agricultural economics student? I think it is quite similar to what this other person is asking.
Oh, okay.
Agricultural economics.
I don't know. And I think I've mentioned like internship has to be based on the country where you are and where you're eligible to work.
Yeah.
So that's one. I'm guessing there might be internships for agricultural economics student in the US. Because I know, for example, Amazon, maybe not AWS, but Amazon as a whole, actually recruits economists. So because there's the Amazon.com part, which is the sort of retail. And so they have all that. But also sometimes for some role, what you read doesn't really matter. I did physics. I'm a machine learning scientist now. So it just depends on the country and the role you're interested in.
Yeah. All right. Questions are quite coming in slowly. I think that, okay, there is one here. What should you do if you have the required skills for a role, but there is a minimum requirement of master's or PhD degree?
I don't know. I don't like that. I feel like it's a lot of gatekeeping that a lot of people do where, they want, I mean, I kind of see I mean, if you do a PhD, for example, you learn a lot of things along the way, how to be independent, how to manage projects, how to fight off ambiguity. So there are a lot of things that you learn, but also I've actually worked with extremely brilliant people that they don't have masters or PhD, and they're probably one of the best. In fact, I can give you a name. There's someone who I can't remember where he is now, but he used to be a professor, a research scientist for Google DeepMind. And in fact, at some point he was offered tenure position to come and be a professor twice. His name is Christopher Ola, and he actually never finished his bachelor's degree. Yeah, let me type his name for you guys. We're gonna search for him. He's probably he's young, maybe 26, 27, something like that. And he's incredibly brilliant. No, what is it called? He doesn't have a bachelor's degree, but he's one of the most brilliant people. And I've had people like that I've worked with. So, but fortunately, some HR and some recruiters were still strict. They still want to restrict it. So what I'll say is that if you find a role that requires that, go and find another role that doesn't require that and keep applying. Yeah.
All right. So find who will accept you and take in your awesomeness. Yep. That's basically what Wale is telling you. Yep. If you're brilliant, go for it and depart from the gates that will not let you in. Exactly. Okay. I don't think that Jane, that's the person that was asking the other question, got back to us on YouTube about the advice of transitioning into data science.
Yeah. Let's answer other people. Yeah. Go on.
Okay. It's all right. Your advice for someone transitioning from computer engineering to data science is what? Isaac.
That's like the easiest transition.
Easiest, yeah.
Computer engineering, you most likely have done advanced maths. So you've done linear algebra, you might have done optimization techniques in undergrad. You've done a lot of all those things. You probably might have done a C++ and a Python. I mean, you don't need my advice. Sorry.
At all. Okay. Yeah. Let me just
that transition works. Yeah.
Okay.
Yeah.
Is there a clear learning path for someone interested in machine learning? Like a straight to the top career path, clear path for someone interested in machine learning?
I mean, for me, I think the funniest thing is that I am not the most optimistic person, but I think there's a clear path to anything you want to do. So, which is, I also think a lot of problem that a lot of people that they face is that they want to learn everything. Like they just want to do this. So if you say, I want to become a machine learning engineer, for example, what do you need to know? You need your machine learning to be extremely solid. You need to understand some of the basics of software engineering. You need to be very good at writing Python. And then you need to understand maybe how to do MLOps, right? And then you want to focus on that. Now, what do you do? There's so many materials, there's so many things, so many programs. Amoye is part of it. You use that to sort of leapfrog. That's a clear path, right, that you started. And then the next step after that is that you want to start building your portfolio. And the first thing is you build your portfolio through two ways. You start building a project on the side, or you start applying for jobs. And another thing is that don't ever think that it's too early for you to apply to jobs. I used to tell people, just apply to jobs and keep failing interviews until you can pass one. All you need is one chance or one shot. And then once you get your one shot, that's it. You, in most cases, you would never have to apply. Okay, for example, I can give you an example. After my first job, I don't think I've ever applied for any job that I got. So which is, if you have a first job, what will happen is that in most cases, recruiters will come and say, oh, there's this job, yeah, there's this, do you want to join? And then you start. So all you need, like I said, is just sort of your one shot. And when you get there, just make sure you're hardworking, do it very well. And always, and one beauty about machine learning and data science as a whole is that I don't think there's a field that you have like rapidly changing, like it moves so fast that if you enjoy learning, it's like you being on a lifelong learning journey, right? So you sort of, I can give you an example, right? Right now, some of the biggest things in deep learning, right? Transformer model, the paper was written 5 years ago. The things that I do now at work that was established 2 years ago, 3 years ago. You do back propagation, maybe not back propagation, you do batch normalization in machine learning. The paper was written in 2014. It was not in the 60s, right? Someone asked a question about TensorFlow 2. TensorFlow 2 was released a few years ago, right? So you sort of, you have like this constant learning, and as long as you're willing to continuously learn, it just gets better. Yeah.
All right. Okay, so basically, person is supposed to get a first job in the line where you want to domicile your career in, and then from there just move up from there. Okay. All right. That's
sorry. Someone asked about Chris Ola, so that's his page that I sent.
Okay. All right.
I wanted to say something about field too. So so when I did a program like a fellowship, you could say it's like an Amway fellowship, but it's mostly for people in like doctoral programs that want to transition to data science and machine learning. I did it years ago when I was starting, and I remember that program, for example, one of the best people that I've met, they all came from social sciences, and they are so good. So I remember there was someone that I was like, what are you doing in your PhD? The person said, oh, I'm doing political science. And I'm like, what? I was like, oh, actually, I'm doing quantitative political science. I'm using NLP and machine learning to track documents in the, what is it called? International Court of Justice in The Hague. And that's all I'm doing, data mining, machine learning. And the person's in a degree in, and I've seen folks like that in neuroscience, in psychology. Their stats background is extremely good. And also the way they see things and answer or probe data science problems is actually different, right? So that's why I like data science field, because no matter the field that you're bringing, you're actually bringing a sort of different set of ideas, right? So it also allows sort of this diversity of ideas from people coming from different fields. Yeah.
Oh, all right. Thank you so much. I think that answers a lot of transitioning questions I have here. I don't think we need to go into all of those again. But one last question I would like to ask, because wow, yeah, because it's already 3:30. Sorry, I will just ask this one and then we'll end it. Is it true? Oh my God, there are two questions. They actually, I have to pick one.
Don't worry, just bring them.
Okay, is it true that there is no entry level for ML as a beginner? Is it advisable to go into ML? And the other one, let me just ask it together. I listened to your talk about feature engineering on YouTube. My question is, how is feature engineering applicable to deep learning techniques?
Oh, okay. I mean, I don't listen to myself.
Okay.
Yeah, the feature engineering. Yeah, I mean, deep learning just basically means you don't need to feature engineer. Sorry. I mean, feature engineering is good
Yeah.
when you have tabular data, and so which means that you want to. I mean, yeah, that was a 2018, 2019 talk in Oregon, that I gave. But I've never listened to it since I gave the talk. But yeah, so feature engineering is when you're using classic machine learning model, it kind of works. Sometimes the way you understand your data and you're able to engineer features can help you get sort of better predictive performance, right? But deep learning, this magic black box doesn't need that. It does all the feature engineering internally, right? And so that's one of the reasons why we talked about explainability, because it is so complex that because you don't even do feature engineering, it does all the millions combination itself. It is so complex for you to be able to explain, right? So that's why we're using, yeah. So that's the difference. Yeah.
The other one is it true there is an entry level role for ML as a beginner? Is it advisable to go into ML?
There's no entry rule. Well, everybody started from somewhere now. I understand, and the truth is that in ML, data science, anything I want to do, getting an entry level role could be extremely difficult. And it's not only ML. ML, I would say the bar is a little bit high because some people, for example, they want to hire ML scientists, right? They're probably much more safer hiring people with PhDs in ML because they probably thought, I mean, which is true, they've done advanced courses and done research, right? So everybody is trying to everybody wants an experienced person, right?
Yeah.
But the truth also is that the ones that are not experienced, people want them to. So in terms of ML hiring, there are shortages. I don't think everybody has everyone they want. So entry level for if you're considering ML, non-ML roles, it's always going to be difficult. But remember what I said, all you need is just that one chance. And when you get that one shot, use it very well. And after that, you'll be fine.
Well, thank you so much. Really grateful, full of gratitude, Wale. We are really, really thankful.
Yeah.
This was a whole lot. You didn't only just do AWS, you also gave a lot of career advice, and that is just perfect. All right, so we've come officially to the end of today's webinar, and I want to thank Wale Akinfadering for taking the time to educate us today. Thank you so much. Every second has been totally worth it. I also want to thank you, our dear interns and visitors, for joining us today. I'm sure you've gained some valuable insights and knowledge. A big thank you as well to the team, Amoye team, and everyone who saw to the success of this webinar. This webinar was extremely successful. I'm sure everyone would bear witness to that. Okay, so until next time, thank you, everyone. Have a lovely weekend. Enjoy the rest of your day as well. Thank you. Bye, everyone.
Bye, everyone. Yeah, thanks for having me.
Bye. Thank you so much, Wale.